Welcome to The Explainer. Today, we're going to unpack the massive, really complex, and, surprisingly fragile system that brings the entire world right to your doorstep. It's this invisible network that powers pretty much everything in our modern lives, and we're about to pull back the curtain on it.
No, seriously, just take a second to think about it. It definitely wasn't magic. It was the result of this colossal, perfectly coordinated effort that literally spans the entire globe, moving stuff on a scale that's, well, it's almost impossible to wrap your head around. Let's start with just how big this whole operation really is.
So let's talk about that scale. The biggest container ships sailing the oceans today can carry over 24,000 of those 20-foot containers. I mean, that's not really a ship anymore. It's basically a floating city of goods, a skyscraper laid on its side, just silently moving everything from your new TV to avocados across the ocean. Now, this incredible physical scale is only possible because there's an equally impressive, though totally invisible, system running in the background. It's a network that's part steel and part silicon, part brawn and part brain, and it's working silently 24/7 just to make our daily lives happen.
Okay, so how in the world do you manage millions of containers moving between thousands of ports without it all just descending into total chaos? Yeah, you can't just wing it. It all comes down to these incredibly sophisticated information systems, this digital nervous system that keeps the whole global heartbeat of trade ticking along.
And here's the thing, there's no single way to run this digital network. If you look at Asia, for example, you see these completely different philosophies at play. You've got Singapore with a fully integrated government-led system, PortNet for the ships, TradeNet for the cargo, it's all super streamlined. Then you contrast that with a place like Hong Kong, which uses a much more decentralized private sector approach, where all the different terminals are kind of running their own separate systems. And this really highlights the two main ways of thinking about it, and each one has a critical trade-off. On one side, you have Singapore's model. It's a centralized single window that's designed for just maximum efficiency. Everything flows through one big government pipeline. But on the other side, Hong Kong's decentralized model, well, it offers more flexibility, but it can create friction and these data gaps between all its different moving parts.
So what's driving all this complexity and all this innovation, whether it's centralized or not, right? Why is there this constant push for more and more efficiency? To put it simply, it's us. Our collective global demand is just relentless.
And that demand is just getting bigger. I mean, just look at the population numbers. We've jumped from 7 billion to over 8.1 billion people on the planet. And more people means more demand for, well, everything. That puts this immense pressure on supply chains to deliver more goods faster than they ever have before. So, to meet this incredible demand, the ships themselves have become absolute behemoths. These new mega vessels, they need ports with a water depth of up to 21 meters. Now, to put that into perspective, that is as deep as a 7-story building is tall. That's a massive, massive engineering challenge for ports all over the world. And the result of all this pressure is basically a global arms race in logistics. Major hubs like Singapore and Shanghai are pouring billions and billions of dollars into automation. We're talking robot cranes, self-driving trucks, and not as a luxury, but as an absolute necessity just to handle the sheer volume and speed that modern trade requires. But this finely tuned global machine, this thing that's been built for speed and for scale, is now sailing directly into a perfect storm. It's facing this really potent mix of new and escalating threats that could disrupt everything we kind of take for granted.
So the first major challenge is environmental. The International Maritime Organization has set this target, called IMO 2050, for the entire shipping industry to hit net zero carbon emissions. Now, this isn't some small tweak. This is forcing a multi-trillion-dollar overhaul of the entire global fleet to run on brand new, very expensive green fuels like LNG, ammonia, or even hydrogen.
And at the exact same time, geopolitical flashpoints are turning what used to be calm shipping lanes into high-risk zones. We're seeing attacks in the Red Sea that are forcing these costly and really lengthy detours all the way around Africa. And then you add to that the disruptions from the war in Ukraine and the rising tensions in the Taiwan Strait and the South China Sea. I mean, it's a minefield out there. And the pressure just keeps mounting. On the ground, you've got climate change causing floods and typhoons that can shut down entire ports for days. A lot of the older ports, they just don't have the infrastructure to handle today's mega ships. And, this is a big one, there's a huge labor shortage. These jobs are often called 3D jobs, dirty, dangerous, and difficult. and fewer people want to do them. So these challenges, they aren't just abstract ideas, right? Let's take a look at how they actually play out in the real world with this fascinating dispute that's brewing between the world's two largest economies, the US and China. Okay, so here's the problem. The US has proposed a fee of roughly $1.5 million every single time a Chinese-built ship docks at an American port. This is a direct economic shot across the bow, and it's specifically targeting major players like the Chinese state-owned shipping giant COSCO. So how does a company like that even respond? Well, their strategy is all about being agile and finding workarounds. They don't just eat the cost. First, they can just charter ships that weren't built in China for their US routes. Easy enough. Second, they can use their alliance partners, swapping cargo space. It's known as a slot charter, so a partnership is the one that actually carries their goods into the US. And third, if all else fails, they can just bypass US ports entirely, docking in Mexico or Canada and then moving all the goods over land. I mean, this one case study is a perfect example of how interconnected everything is. A political decision made in Washington forces a huge logistical pivot that sends ships to ports in Mexico. It shows both the fragility and, frankly, the incredible adaptability of this global network. So it leaves us with a really critical question. As this system faces just immense pressure from all sides, how resilient is it, really? Thanks for joining us for this explainer.